Welcome to the Austin Forum Upload, the podcast of the Austin Forum on technology and society.
Every episode, we upload for you the expertise, insights, and opinions of thought leaders, innovators, and creators on topics at the intersection of technology and society.
We'll cover pervasive and emerging technologies that are influencing and impacting our business, education, governments, research, and culture.
I'm Jay.
I'm Jessica.
And I'm John.
And we're the co-producers of the Austin Forum Upload.
Hi, and welcome to the Austin Forum Upload. I'm John Lockman.
And I'm Jay Boisseau. We're the co-producers of the Austin Forum Upload, and we're very pleased to have our friend Jason Shepard joining us on the show today. Welcome, Jason.
Thank you. Thanks for having me. Really excited to be here. I love talking about IoT and edge and all things in between.
Well, and we're going to start with that. Why don't you tell us just a little bit about yourself and your role? And then right after that, we're going to ask you to define IoT and edge computing.
Sure. Yeah. So I'll start by saying if it's fuzzy, I'm on it. I've been doing, kind of R&D, CTO type stuff for a long time. I always find myself at the beginnings of new market trends. So actually when previously to Zedita, where here I lead our ecosystem efforts, that's both in the commercial partnership sense, also open source community. I serve as our field CTO. I kind of sit between engineering, marketing, and sales and help kind of bridge the gaps. So know the market really well. Actually, we worked together previously at Dell, started the IoT business back in 2014 from CTO with a small group of people. What do we want to do with this buzzword IoT? That was kind of when it started heating up. And then over time, it became in the market more about edge. And, we can talk about the differences. Worked on it, probably I've been doing edge and IoT for about the past 7 years. I left Dell as the CTO for IoT and edge and came over to Zedita. And, we'll talk through some of the why behind that and where we're headed. But I always find myself at the beginning of new markets. And, I'm big into the people part of technology. Good technology sort of disappears.
Well, let's start with that difference too. So maybe for our listeners, you can define Internet of Things or IoT and define edge computing, which we often just abbreviate edge. So if you can sort of define and maybe even talk about any differences that you use at Zedita in those terms.
Yeah, so IoT is basically represents embedded computing hitting scale. So more processing, more sensing, everywhere. IoT is not a thing, it's more of a concept. When we did it early days at Dell, people would come to us as like, I want to buy some IoT. Oh, really? What color would you like? It's like, it's basically this practice of taking sensors to collect data from the physical world, connecting to legacy systems, but usually just for monitoring. You're not going to go just start controlling, process control from the cloud. You just don't do that. There's safety issues, there's uptime issues. But gathering data, bridging the physical world to the digital world, initially often for monitoring, but then of course, starting to deploy more analytics over time to drive optimizations. That's sort of in the enterprise sense. And then the consumer sense, smart home is an obvious example. I argue, Alexa, Alexa is an IoT device that's a thing inside your house. It's got, various sensors in it. It bridges together a smart home. And we'll talk about, I think it's important to talk about some of the trends and why we saw what we're seeing in consumer versus the fragmentation in enterprise. Not that consumer isn't a mess still too, but it's sensor-driven analytics. In the broader sense, edge computing became a hot topic over the past couple of years. Well, a couple of reasons. Number one, people kind of got tired of IoT. You got to have a new thing to talk about. So it's 5G, edge, AI, whatever. But also, as you see more devices generating data on networks, now you drive bandwidth problems. You drive latency issues. You've got new types of services, both upload and download. The internet was built for download, not upload. So there's all these reasons why you have to move processing closer to devices. So IoT was kind of like a instigator for edge because there's going to be an order of magnitude more devices on networks than people over time. And, kind of evolves from there, but also edge includes other use cases. And we can kind of talk about that in terms of how Zedita is approaching it.
Well, why don't you share a great consumer IoT or edge computing success story and maybe one great enterprise success story that are good examples to sort of drive those points home?
Yeah, I mean, IoT is the success story was it's Amazon. I mean, when we started in 2014, leading to 15, as we were working with the team, I'm like, hey guys, we're not going to do consumer. I'm calling it right now. This is way before Alexa. Amazon's going to win round one. The reason why Amazon kind of run, Google Play's doing okay, good. Apple hasn't really shown up yet, is because in consumer, people build trust with certain brands. And if you trust something, you will give up a little privacy and to get value, and not everyone, will have an Alexa or whatever, but it becomes that smart, hub of your home. Because Amazon sells you not only content, but also stuff, it's the double whammy. I know my UPS person by first name. They had the edge. And so that's why they became, really quickly the anchor point of the Alexa ecosystem. And so that's the most well-known, I think, success story of IoT in terms of an ecosystem, and just kind of bridging together smart home. It's still super fragmented, it's still complicated, but that it requires aggregation around an anchor point, and they have the edge there. So, that's kind of where I see as a success story. In commercial, there's a lot of smaller successes, in terms of, not this macro ecosystem like Amazon, taking over so many different parts of the market, but we see a lot of things around. We're working in areas around like oil and gas analytics of oil wells. They're using sensors to figure out, is the well producing properly? Is it healthy? Where are the resources? We see a lot of people talking about and deploying things around predictive maintenance. Use sensors to drive analytics around when is a machine going to fail. In fact, actually, we're working with a turbine company, wind energy company, and they're deploying compute some boxes inside of the nacelles of wind turbines, and they're using audio data combined with current and voltage and whatnot. But you can learn a lot from audio, especially video data. It's very rich in information, and then they can start to kind of look for anomalies. So these are the types of things. I mean, is there like a massive commercial success story that's just dominated everywhere? I don't think that we're there yet, but there's a lot of like really good business problems being solved. It's just been more organic. There was never why are people tired of talking about IoT? Because there was never like the big bang, like everything's magically solved by IoT. It's the word is going away. All new tech trends start with, here's a buzzword. Let's talk about it. Let's go make money. It's going to be awesome. We're going to make all this new money. And then they realize, well, this is challenging. And then it sort of silently fades away, and it's just part of life. Do we talk about the internet now? Do we say, oh, I'm going to do some e-commerce today? It's just something you do. So that's where we're at with IoT. I joke we were at the AOL stage of IoT before. You just get things online, and we're kind of coming out. And now the hot topic is edge, AI, 5G, et cetera.
So I think you touched on a lot of things in both the enterprise and in the consumer space. There's a lot of different pieces that are making up IoT, whether it's software or sensors or different types of hardware. What are some of the key technologies that are really enabling IoT today?
Yeah, so it starts with that physical digital bridge. So sensing. This can be sensing embedded within a device, within your car, an Alexa, or or package sensors that you attach to machines, or whatever. Those, of course, communicate over certain protocols that then gets aggregated. Some devices go straight to the cloud. Some start to get aggregated on premise, and then that turns it into data that then goes to the cloud. So that would be like the gateway concept. Often, the cloud's an easy button. We've seen a lot of trends over the cloud, but then now what's happening is we're seeing people pull back a little bit, and it's about the edge to cloud continuum, because a lot of projects over the past 5 years for IoT started with cloud, and then people got the bill. They realized that sending data like it's 72 degrees, it's 72 degrees. By the way, did I mention it's 72 degrees? Constantly to the cloud is very expensive versus, hey, it changed from 72 degrees. It send the deltas. So the technologies, it's sensing, it's different protocols. It's crazy town, the number of protocols out there. There are limited standards. IoT is born from a lot of things that have been done for a long time. That's why I say it's embedded computing hitting scale. The name of the game for many years was industrial players, people doing control systems and process automation and all that, would create proprietary protocols to lock you into their systems. Open always wins in the end for scale. So now what's happening is you're seeing more open interoperability efforts. It's just like the internet. Internet started as proprietary, kind of these segmented things, fragmented, and then they all got together and figured out standards. And look what happened. IoT is sort of getting out of that, but the challenge is there's so much legacy, so many different protocols, so many different software stacks, and all this different stuff, that trying to pick one magical connectivity protocol that makes everything work together, it's never going to happen. This is why we're seeing open source communities start to build these interoperability frameworks. Open source is the new way to drive standards. You coalesce around a framework and APIs, and then it doesn't matter what you talk around the middle, because the moment you pick one thing in IoT, you're wrong to everybody, or a lot of people. And so you need to bridge these things together. So it's sensing, kind of edge hardware, these frameworks, whether they're commercial or proprietary. Then you start populating in databases and AI. Increasingly with edge, you're going to see those populated locally. But then, of course, sometimes the data is just going to go to the cloud. It just depends on what you're doing. But it's this continuum of different layers of technology. So it's just a bunch of different things put together in the right way to drive outcomes through sensor-driven analytics.
So many years ago in my undergrad, I worked with a group called the Texas Coastal Ocean Observation Network, and they built little sensors that went out into the Gulf of Mexico to read these sort of things, weather and wind and wave periods and things like that. That wasn't as hard. And like you said, there was always the decisions about send deltas, don't send the same data all the time. Specifically out there, it was the only way to get data out was through a satellite connection. Mm-hmm. Very expensive, very small windows to actually send data because you're sharing it with a lot of folks. What are the technologies that are changing in that space?
Yeah, I know, it's a great point. So satellite is still widely used if I'm doing a mine or I'm out in an oil rig or whatnot, but that's exactly why you want to pre-process data. You got a straw, you can't be pumping a flood through it. Clearly there's folks that do have the option of attaching to a fiber network directly. Then there's a lot of people that are going over cell or something like that. Interestingly, so connectivity is becoming more ubiquitous, cheaper. There's still big problems in rural areas. That's why you see the efforts around like Magma from Facebook and the balloons and all that kind of stuff. But still, there's low band, low power wireless, like LoRa and stuff, where I can do low bit connectivity over unlicensed networks over long miles of range. So LoRa is good for I'm here, I'm not, I'm on, I'm off. But you would not send mission critical because it's on unlicensed spectrum. We're just seeing more and more technologies for connectivity. But the other thing that matters here is stakeholder complexity. OT versus IT in a factory. There is a lot of OT being like, oh, hey, I want to put this on my network to gather data out of the process and maybe send it to Azure or something like that. And IT is like, hell no, are you going to put that on my network? Because I own the network and all that. And so then the battle ensues. And then what happens sometimes is OTs are like, okay, fine, I'll put it on cell and bypass you. We see this all the time. So that's not only like what options for connectivity do you have, and maybe you have multiple, when I can get cell, cool, otherwise I'll fall back to satellite or whatever. So this context switching, but it's also like complexities around who owns the network. Can you get along? Because there's a lot of not my job, that scares me, I don't have the skills, that's going to expose me, that's going to expose that I'm terribly inefficient. It's complicated.
Yeah, Jason, you gave a talk once that at Dell when we were both there that I really appreciated, where I think you sort of said, imagine the difficulties we have right now with just trying to make Windows and Mac and Linux talk to each other. Yeah. And then think about the thousands and tens of thousands and hundreds of thousands potentially of different kinds of devices that are out there. And we have to make all of these talk to each other according to some standards. And then there's all these different communications protocols between all of those different kinds of endpoints. So just the hardware complexity alone is tremendous. And that almost fosters this desire for people to especially in the early days, create their own software environment to make their own devices talk to each other. So you get these little ecosystems. One thing, though, that I'd like you to comment on is this, I guess it's called Project CHIP, the Connected Home over IP initiative. Are you familiar with that one?
Loosely. I mean, I know the general principles, but yeah, we're seeing a lot of these types of efforts coming on to try to bridge the divide.
Yeah, I think those kinds of things are needed. And the chip for home is only for smart homes. It's not for, mines and oil wells and factories and stuff. But are you seeing much move towards standards to prevent the cloud edge lock-in of ecosystems from, say, certain hyperscalers?
Yeah, we're seeing it. I think from the time when we started, at Dell, like to now, any new market, it's always, I'm going to own everything. It's awesome. And then people are like, oh man, this is painful. And maybe I should like do adjacencies versus try to completely reinvent my business. And so the past 5 years in IoT have been that pattern. So you're probably familiar, I started with a small group of people at Dell, this project called EdgeX Foundry, which is around, interoperability. Don't pick a standard and make them work together. It's kind of, similar to the other one, and there's some other ones. And that went from like 0 to 300,000 downloads for the first 3 years. And in the past year, it's had 7 million downloads. And so I liken it to like, I got this all figured out. I don't need interoperability. Holy crap, this is hard. And then it takes off. And we're seeing that. So people are starting to realize, maybe the internet, if it wasn't open and interoperable, things wouldn't have panned out so well. And so we're starting to see people mobilize more and more. We're not there yet, around open standards, and the winners will have necessarily unique hardware, software, and services around that open standard, kind of like how the internet created massive economic value and brought people together. It just takes some time to have people feel enough pain to want to go there. And I think we're getting out of that phase. IoT is especially hard when it comes to this because, of course, we got the internet. If you're a sentient being, I don't understand someone talking in German online, or I can pick out a word or two, but as long as someone talks a semblance of English, I can connect the dots, different dialects or different accents, but I can connect the dots. If you're a thing, you must be programmed to understand exact semantics. And that makes it much more fragmented than, people on the internet, so to speak, because you can connect the dots. And these dialects of all these protocols is what really complicates things. Data models that you have to be structured. I think AI is going to come in and start to help bridge that gap. I can figure out context between different protocols versus it having to be hard coded. That's going to come, and then of course, we're going to need AI to combat AI as the bots come. But yeah, this is the challenge. But I'll also say the top two challenges with IoT, and we should talk about edge, top two challenges with IoT or any technology have nothing to do with technology. It's business case and people. Again, it's not my job. That scares me. It exposes me. That's the challenge, and why IoT has taken a while, but it is happening. It's just not the big bang, like I mentioned. All of these technologies, so there's IoT, then there's, edge is a hot topic. A lot of people like to talk about 5G is going to save the world. 5G, very important. I don't think it's going to make nearly as big of an impact in consumer as the telcos would love you to believe, to pay more for the connection. Because if you're streaming things, your current speed's good enough. You're going to have a good experience.
I think John and you practiced this little bit right here. John has said anything to me so many times about 5G.
Yeah, it's until the applications catch up, 5G is not going to benefit you that much in the consumer space. You're seeing a lot around private 5G, and 5G is not one technology. Of course, there's NB-IoT. There's all these different things and license and CBRS spectrums, and 5G to me it's going to be enterprise first. It's going to be more around new business models than even the technology itself. You're going to see with private 5G, which kind of stems off of private LTE, more non-telco providers offering connectivity into environments. Like, Siemens is starting to offer industrial connectivity into factories. 5G becomes the new pervasive Wi-Fi with local small cells, completely bypassing a telco. Some are partnering with telcos, but they bring, I know how a factory works, how a network works, let's partner. But if the telcos don't get ahead of trying to own everything and stop trying to, again, be in the data path, and every tech transition, the telcos try to own more. Like, I don't want to just be the pipe. But the reality is there's ways to own more without trying to be in the middle of it, because trying to be in the middle of it is like trying to be in the internet, the internet. That won't work. So we're going to see, these colo players, the regional data centers, they're going to be offering new services. It's all going to blur who offers what to who. As we get into the service economy, it's not going to be the same players.
Well, let's try to big picture this again for our listeners. I just want to make sure that we summarize what we've got so far.
Yeah.
So it's about these sensors and potentially actuators that are connected in some way. They might be connected to clouds or to data centers. Increasingly, they may be connected to each other in the future. And as you have more and more of these devices, you may want them to be more powerful as well and process data before pushing it over the network and flooding the network. So on the there's sort of two competing things here, aren't there? One is you'd love to connect more and more, sense more and more things about your environments and be able to act on those. But the more of them you sense, the more data it is. So you want to do more of that processing in some of these applications where you're actually either sensing the data or making the decision that comes from sensing the data. So that leads to more edge computing, not just edge sensing or edge actuating, but more edge computing to help make some things even autonomous at the edges, right?
Oh yeah. Yeah. And there's a big difference between, so bandwidth is the number one driver that we find, it costs money to move data around.
Right.
And bandwidth is expensive. Just because 5G is fast doesn't mean that, it costs, it's free. And then 5G also creates a problem is like, okay, hey, it's so fast. Well, guess what? It's fast between that cell, like the small cell right near you, but then it's the same speed going upstream. So you still have to process the data locally before you can feed the smaller pipe up. But anyway, so the edge trend is coming for that reason. Edge computing is a continuum from constrained devices up through sort of compute in the field, maybe embedded in a machine. It's getting more and more capable. Then I get into the on-prem data center. Then I get into regional data centers. Then I get into the centralized cloud. The whole point with edge is that I want to be able to move workloads from the cloud to the edge. And it's all about a balance of performance versus cost. The cloud scales in density, the edge scales in distributed volume. And so it's just a different factor. Tens of public clouds that matter in the end of things, trillions of constrained devices, millions of dollars for infrastructure, $1 for a device. It's just an exponential scale. You can't use the same tools that you use in the data center as you do at the edge. There's 3 inflection points. If for those listening, if you want to learn more about edge computing, the LF Edge project within Linux Foundation, there's a white paper. You just search LF Edge taxonomy paper, and it goes into great depth because a lot of people are confused about edge because people say near edge, far edge, thin edge, thick edge, industrial edge, AI edge, blah, blah, blah. I joke near and far. It's like Grover approves, but otherwise, near, far, like no one else approves because it's ambiguous. So that white paper goes through 3 key paradigm shifts. Is it latency critical or is it latency sensitive? That workload. If it's latency critical, your airbag, you will never, ever do it over a wide area network like 5G. I don't care how fast it is, how reliable it is, never will you do that. So a car, autonomous vehicle, the car itself has all the systems, computer vision, all that stuff locally. That's latency critical. Put the brakes on, okay, cool. But higher up edges, in the service provider sense, on the other side of the wide area network, on 5G, LTE, whatever, they will help coordinate cars as they approach intersections. So it's latency sensitive. I'm augmenting, but I'm not driving the car. I'm providing augmented reality services, infotainment stuff. No one's going to die if your radio show shuts off or Netflix. So that's a difference. One is it latency critical, latency sensitive. Another one is, are you in a physically secure data center or are you not? Once you get outside of a data center and now people can walk up to that box, you get Stuxnet where I stick in a USB key. Very different scenario. The last paradigm that this white paper goes through is the device so constrained that it has to be embedded software development? So it's custom software for every device. And that's where you're seeing like TinyML and stuff. Or is it have enough horsepower to where I can apply containerization or virtualization? I can literally abstract workloads. Once you can do that, your life becomes a lot easier because you can deploy applications once and deploy them anywhere, or develop once and deploy anywhere. So, for example, Zadita, we complement like a VMware, Nutanix, the OpenShifts of the world that do data center stuff. They come down to on-prem data center, but then you start getting into this next paradigm where it's like outside the data center, but still capable of running virtualization. That's what we do. High levels of security. We assume you're going to lose connection out in the field because you're on that satellite connection. We assume that someone's going to walk up to the box and start trying to tamper with it. So you need a robust security model different than the data center. We assume that the box has to phone home. Data center paradigm is the controller phones the server and says, hey, you should do this. Here's my updates. And it has a constant connection pretty much. stuff out in the field, edge computing out in the distributed field, they're going to lose connections. You got to assume that, and they have to phone home and they have to say, hey, what am I supposed to have? And then you download stuff, and you need to do uptime. So everyone talks about edge and it's it's myopic vision. This is my edge. This is why all compute's going to happen here. It's like, oh, did you get the memo? There's more and more constrained devices doing tiny ML that are making decisions locally, granted fixed function. So first with edge is it's a continuum, not one thing. That's key.
So we're automating manufacturing and facilities and vehicles, and pretty much everything is being instrumented in the world right now. I'm really excited about what you just said of, basically turning it all into a whole containerized workload where it doesn't matter where I run it. Is it in my data center or is it out at the edge? Who cares? It's still the same little container that we can ship around. That's exciting to me, but what else should other people get excited about? What's coming next?
Okay, so the next big thing. So I worked on EdgeX Foundry, and we're still very involved. Zadita's offered. By the way, like part of the reason I chose Zadita, I didn't interview anywhere else. I wanted to get back in the startup world. I'm like, hey, all my blogs, you could put Zadita on them, and it reads the same. So I should just come work for you. I knew our CEO, Said, pretty well. So we started. But Dell was great. We had a great time there for 13 years. But anyway, so the next big thing. So we're getting better on interoperability. People are starting to kind of get past learning how to spell edge. We're getting out of this buzz phase. AI is definitely taking off. There is still a lot of buzz around it. There's challenges in the real world. I always say, go Google Chihuahua muffin AI. Have you ever done that? You'll see like little cute Chihuahuas and then blueberry muffins, and they can't tell the difference between the two. And then, of course, combating AI with AI. There's some scary stuff coming. But related to that, the next big conversation, and something that I've been involved with the community, is going to be around trust. This notion of, on the one side, I would like to start creating more and more interconnected ecosystems. Internet of Things is a misnomer. Everything talking to everything anytime soon, not going to happen. There are a series of increasingly larger intranets, and you connect those intranets when there's business reason or value gained. So, what might start as like a closed smart home, wouldn't it be cool if beyond Amazon, you can see retailers, utility providers, healthcare, insurance starting to cross over and giving you new services. And the average consumer will give up some privacy if they get value. And so to do that, though, they have to trust the entity that's giving them that value. If you want to have any to any, Internet of Things, AI, 5G, all this stuff kind of interconnected and driving new outcomes and experiences and business models, you have to automate trust. And so the next big thing that I've been working on with a bunch of folks, we launched it. It got a little bit of a COVID delay. We announced it actually from Dell November 2019. It's called Project Alvarium. You can go to alvarium.org. There's a cool video there. There's a lot of efforts starting to spin up, and it's really about collaborating. It's not about one or the other, but really cool stuff. It's this notion of start taking all these technologies and connect them together into a fabric to create these trust fabrics. And the video walks through all of it on the website, and there's more things online. And we're actually officially launching a working group within Linux Foundation, probably within the next quarter, if not sooner, working with Dell and Intel and IOTA Foundation and others. It's an open project. But it's this notion of trust fabric. So no, it's not just blockchain. Blockchain was a hot topic. Then people realized there's some challenges, with compute required and exposure and all that. And then the IOTA, we picked when we were working on this, IOTA Foundation and the IOTA protocol is very efficient. So but it's not about one technology. It's a layered fabric from silicon root of trust, confidential computing, immutable storage, you can't tamper with it, ledger technologies, open APIs, all of this stuff bound together with a framework. That's what Alvarium is. And then the kicker is I apply a confidence score to that data. So if data flows through the way I built a trust fabric, considering what I've chosen, it could flow through and I could apply metadata to that data and say, this sensor value, I'll sell it for this price. And as it flows through, it's 80% confident. Do you want to buy it? Or I'll share it with you and it's 100% confident, or it's 20%. And then your fabric intersects with someone else's fabric and there's boundary conditions. And it's like the internet on steroids. It's the measured confidence of interactions across the internet And it matters because you can't take people out to dinner with drinks fast enough to build trust at scale. You have to automate it across these heterogeneous systems. So this is a longer path. I know, like it'll happen in supply chains and smaller things, but imagine a world where a telco who owns a house over Amazon? It's your internet provider. 90% of home gateways are the internet provider for your house. If a telco was to offer a home edge computing box that they could deploy applications from anybody on, retailers, insurance providers, all utilities, all that, in a trusted fashion, so you knew that the data wouldn't get cross-pollinated unless you set up services, privacy value balance, you could drive entirely new experiences. And now Amazon, great company. I mean, again, I use Amazon all the time, but they become a service to that meta service. And what happened is you just disaggregated the trust. And it has to happen at a system level. Blockchain just tells you where the data went. It doesn't tell you if it was any good. So just massive business potential. If you watch that video, there's a reason why we put a telco, kind of a service provider in the middle. Do you become service providers for service providers? And this gets back to don't try to own it. The best thing you could do is become the hub for the trust and offer services on that. And there's massive amounts of money. But if you try to own it, you basically just alienated yourself in party of one. So, long story, it's a cool video to watch, and we're definitely, headed that way. But the net message is you'll never get to the promised land if you don't start with an open foundation today. Never will ever happen.
All right. Well, that may be a good closing thought. Are there any other final thoughts? You've given a few references for our audience to check out. lfedge.org was one of them, and alvarium.org.
Yeah, alvarium.org. A lot of good resources out there. I think the net message is don't reinvent the wheel. Don't do what we would call undifferentiated heavy lifting. This is what open source is for. Let's collaborate on the base. Open source is the modern way to drive standards. Spend your time on necessarily unique hardware, software, and services. Domain knowledge wins in the end. Even AI, commodity, license plate detection, facial recognition, there's no money to be made. They're going to be commodities. The money is in domain-specific AI models that you can apply and whatnot. So just stop reinvention. And there's been a lot of reinvention in IoT, 400 IoT platforms. I can't tell you how many conversations I've had. Oh, I'm so unique. I can collect sensor data and put it in. I'm sorry, get in line. So we're seeing that shift today. So I think the net message is focus on open, embrace it. Look towards the future of these interconnected ecosystems. It's a journey. Let's not say that it's going to happen overnight, but just get on the path.
All right. Well, Jason, thank you very much for joining us, and look forward to having you visit the Austin Forum again and present in the future. We're going to be back in person before long, and we look forward to not only having you present in a longer format, but hopefully instrumenting the in-person facility with various devices. And maybe at that point, we can even figure out a way to have our online viewers of that event leverage their smartphones as devices in this interesting distributed collection of we'll call it a sub IoT, an Austin Forum Internet of Things. So
a FIOT.
There you go. Thanks for joining us, Jason, and we really appreciate it.
Yeah, thank you. Thanks for having me.
Thanks for listening to the Austin Forum Upload. You can listen to additional episodes and check out a schedule of our monthly in-person events at austinforum.org. The Upload is a production of the Austin Forum on Technology and Society, a nonprofit organization here in Austin, Texas.